Hello, everyone, and thanks for joining this session. My name is Will Florentino from Micron Technology. Today, I'd like to talk to you about how industrial IoT connectivity is evolving and how edge compute solutions are becoming an essential part in bridging IT and OT domains. And as companies develop their edge strategies, I'd like to highlight how memory plays an essential role in the success of next generation edge solutions. We realize that there's a societal shift in connectivity and compute and how AI is transforming all segments from smart factories and infrastructure to transportation to medical devices, and certainly will drive new opportunities as part of industry's digital transformation. Here are just a few data points of how markets are growing in an ever connected industry. For one, it's estimated that there will be 41 billion IoT devices connected by 2027, or that the edge compute market is going to grow to almost 30 billion by 2025. And in just 3 years, 70% of cars will be anticipated to be connected to the internet. All of these are examples that highlight the fact that every segment will benefit from a connected solution. So it will be critical for us to understand how connectivity architectures are evolving. When we look at a typical IoT architecture, it was driven by enterprise and cloud platforms looking to use their massive infrastructure to support the supposed IoT promise of billions of connected devices. So the idea was to send the data to the cloud and then would provide analytics and actionable insight. These devices, such as simple gateways and routers or switches, bridged between these domains and were considered as aggregators or protocol translators. But the main compute was still done in the cloud. However, as industry moved from proof of concepts to real world implementation, they realized that industrial systems needed real time, persistent connectivity. They needed analytics closer to the endpoints, opportunities to develop layered security, and of course, try to reduce their cost of connectivity. So, because of these challenges, industry realized that if you shift left these cloud functions closer to the data source, it will result in more real time compute and allow for more efficient data management. As a result, these older routers and switches that are being replaced or being supplemented with intelligent gateways and edge servers. And that's the reason why software IoT platform providers are focused on developing solutions for the edge as well, and why traditional hardware players that used to just build pure networking devices now find themselves expanding into more intelligent edge solutions. The hardware and software architectures will vary widely and will grow in complexity. We know that lower latency and higher throughput will be key in any edge compute requirements. Gateways that used to be simple store and forward function will be embedded with cloud agents and IoT protocol stacks. Network server platforms will evolve to more complex, ruggedized edge appliances that will leverage multi-core processors, FPGAs, or ASICs with accelerators for AI inference. The IoT edge software platforms will support containers or modules that could isolate paths for a specific application or function and allow for multi-tenancy. As a result, the code size will increase all up to 200x just to accommodate all these new applications and functions. Storage will certainly grow from the megabyte range to the terabyte range as it ingests and manages this millisecond high fidelity data that is delivered into the system for analysis. And of course, they will need another layer of security to prevent outside threats. I think it is clear there will be a race to the edge, as it once did when industry initially scrambled to have their own IoT story. We see traditional OEMs in networking, automation, cellular IoT, and even enterprise developing edge-focused solutions because they see what it will provide, such as new revenue streams, an opportunity to expand their portfolio. It'll help them to enhance their R&D, even provide some strategic partnerships with technology synergies, and probably even gain market leadership. And with the promise of 5G technology, with 10x lower latency compared to 4G and 20x faster data rates, 5G will impact the way we see wireless technologies in industrial applications as well as the edge. Whereas 4G was just used as a transport mechanism to send data to the cloud, 5G will now be an integral part of the real-time data processing operation that is synchronized with the edge in the cloud and provide optimal data insights. The complexity of edge systems will need to operate a comprehensive set of functions that will support various elements from security and authentication to edge compute and analytics to supporting microservices and virtual functions. Memory, there, memory therefore, must be able to support these requirements from non-volatile memory solutions to secure code and data to high-performance DRAM with wide bus width to support AI-enabled devices and storage that can offer intelligent partitioning and high endurance in industrial environments. So basically, to develop an edge solution, you will need a full portfolio of memory technologies for industrial use cases. As we have identified the memory requirements, Micron delivers what I call the complete edge essentials. First is we have an extensive set of DRAM solutions to help with compute needs at the edge. We have DDR3 and DDR4, which are market proven in full extension of our products, as well as LPDDR5X that has data rates up to 8.5 gigabits per second and up to a by 64 bus with package solutions. We have DRAM and LPDRAM both in our product longevity program because we do know that this is for industrial use case. And we have an extensive DRAM module offering, including UDIMMs and RDIMMs and SODIMMs as part of those solutions. Second, we have a broad range of NOR and NAND solutions for code and data storage. We support SLC NAND as well as TLC NAND and with OTP data protection. We have a unique Accela flash, which is an octal SPI flash that has SDR DDR speed interface and up to 400 megabytes per second reads. We support eMMCs with internal NAND management. We have micro SD cards up to 1 terabyte and a robust hardware-based security solution in our NOR and NAND with Authenta-enabled devices that has a very unique key management service as well. We also support multi-chip package solutions for space-constrained devices that could save 30 to 40% of board space. And we provide that through vertical stacking at die level or a POP as well. We support NAND MCPs as well as a good portfolio of eMCPs as well. Micron also delivers a wide range of industrial grade, auto grade, and enterprise grade storage solutions. For example, our 2100 series 3D TLC SSD was the industry's first 1 terabyte auto and industrial grade NVMe flash storage. The benefits for edge application is on superior performance at the highest densities in a small form factor. It supports end-to-end data path protection, supports SLC intelligent partitioning, and has an efficient power management solution. And it is designed for reliability and robustness with industry compliance, including AEC Q100 for demanding automotive use cases. So I'd like to thank you for your time today, and hopefully I was able to highlight how memory plays an essential part in this new edge domain. This is definitely an exciting time for industrial IoT connectivity, and we hope for that opportunity to work with you to help you win that race to the edge. Thank you very much.